Hello everybody, this is Itsu. I was a little bit amazed by the statement from WhatsApp that he made some measurements on his coaxial cable and that he was pulsing his inner connector with high voltage and that he could not see absolutely nothing on the shield from the cable. So I was also experimenting with coaxial cable and high voltage, and what I found is that there is certainly a very big spike on the shield, and even if you couple two coax cables, there is a big spike on the outside and on the inner of the secondary. So I made this contraption. It's normal TV 75 ohm coaxial cable. I have about 31 turns clockwise. It's the inner, the primary I will call it, and it comes out here. And I have then the secondary, and that's wound counterclockwise over the primary coil. I call it the secondary coil. The coax cable I used is, like I said, 75 ohm coax cable. It has a solid center core, and it has both the aluminium shielding and a braid-like outer shielding. So it's very well shielded. What did I do? I have here my function generator, my little Chinese one. It's set to square wave 50% and frequency is 110 kilohertz. And I feed it to a MOSFET type of pulser, which is pulsing this flyback. And the output of the flyback goes to my homemade spark gap adjustable. Right side is a copper bar and the other side is a carbon bar, and that goes to the center of the primary coax cable and out back to the return of the flyback. The flyback has its internal diodes, and I also hooked up the internal capacitor, which is about 3 nanofarad if I measured correctly. So I have a DC pulsed, and I will pulse the primary coil. I did measure the outside of the inside of the secondary coil, and there I have about 1000 volts of peak. So there's definitely a very large peak coming through the both shieldings to the outer casing. On top of that, I made some kind of copper tubing third coil, pickup coil. It has 7 turns, so 31 to 7. It's lower the ratio, and I will measure the pulse on the red scope. And I have set the yellow probe to across the function generator. It's 110 kilohertz at the moment, and I will pulse now with 12 volts on the you can see the spark and hear the spark. And this is the pulse I get, and you can see it's 750 800 volts, 23, 12 megahertz, 25 megahertz, because that's the ratio of the pickup coil, I think. So I definitely have a very big spike on this pickup coil, I call it, this third coil, and this goes through the both shielding of the coaxial cable. If I put the probe at the secondary, but I'm a little bit afraid that it will damage my scope because it's not up to this high voltage, of course. So that's a little bit my experiments I'm doing. So my coax cables, when I push them with high voltage spikes, it definitely will transfer through the shielding and being picked up outside. So I will do some more measurements with this kind of coaxial cables. Okay, thank you for watching.